This is section 8.3. And today we're going to be learning about addition versus elimination thermodynamics. And the reason why we're learning about this is because if you have an alkene, you can perform an addition, such as this hydrohalogenation, meaning that we add a hydrogen and a halogen across the double bond. But the converse of that reaction, or the opposite, is that you can also eliminate the H and the X to give you the alkene in an E2 fashion or an E1 fashion, as we learned from chapter 7. So the question is, why would you have addition or elimination? What thermodynamic factors are going to be governing these two reactions? So let's think about the Gibbs free energy equation. Remember, we're going to be talking about the free energy of a reaction, and that's going to have an enthalpy term and an entropy term. And also remember that if you have a spontaneous reaction, meaning that it happens without any special circumstances, delta G needs to be negative. So delta H needs to be negative probably, and delta S should probably be as small as possible. That way we don't subtract too much away from it. If delta S is negative, which it probably will be, hopefully, then this should be spontaneous as well. So let's think about this reaction. So we have two molecules, a double bond alkene and HX, and they go to one molecule. That is not good for our entropy term, right? Because we are taking two molecules into one. That means there's less disorder. That means entropy goes down. So it's negative. So that means this could be a positive value. So as the entropy term gets larger, it's actually going to be fighting against the enthalpy term. And we really have to hope that the enthalpy term is very big. Otherwise, this reaction won't be spontaneous. Okay, so looking a little more closely at our reaction, we are going to be breaking one double bond and one single bond, but we're going to be forming two single bonds. The good news for us is that it takes a lot more energy to break or form a single bond. So since we're breaking a double bond and a single bond, and we're forming two single bonds, that's more than enough energy to make sure that our enthalpy term, delta H, is in fact negative. But it does still mean that the entropy term is positive. So what we have to hope is that in the addition, we keep the temperature low, because this is going to be a temperature-dependent reaction. As long as the T term is low, then this positive entropy term is also going to be low. The converse of that is that since the addition will not be spontaneous if the temperature gets too high, that means the elimination will be spontaneous if the temperature gets to be too high. So high temperature favors elimination back to the alkene, and low temperature favors addition away from the alkene reactant. And that's shown here. Low T and strong acid give you the addition product. High T eliminates the hydrogen and the halogen to give you the alkene. This was section 8.3.